Awesome. Thank you, Adrian. Thank you, everyone, for being here in this event. And also, thank you for hosting this event, VMware. The next event will be in our AWS office in November. So hope to see you again there. Today, I'm going to introduce the topic of infrastructure as code. My name is June. I'm a solutions architect at AWS and based in Zurich. Marta, do you want to introduce yourself?
Sure. I'm a solution architect. Well, I guess you cannot hear the microphone, but I'm a solution architect as well in Zurich, just like June.
Great. So solutions architect as a role at AWS is to help our customers understand better the technologies from AWS and also advise them on the solution designs. Yeah. The reason we bring up this topic today, infrastructure as a code, is because it's become a hot topic. And we are having more service releases and discussions around this domain. First, just a question. How many of you are already using CDK and cdk8s to provision your infrastructure and define your Kubernetes applications here? You can raise your hand. None of them? None of you? OK. So it seems like it's a very necessary topic to introduce today. I mean, it's fair because it's also a fairly new topic. Let's start the presentation, but let's first do an imagination of the building a cloud application. Here I put an analogy here. So building a cloud application and provisioning infrastructure below it, it's just like building a skyscraper. Why? Because both are associated with many complicated components and it needs different teams to contribute to it. Actually, this building is the Amazon Berlin office, which will be completed next year. It's going to be the tallest building in Berlin. Great. So there are several teams. I break it down into three. The first team is a construction team who will build the building brick by brick. The second one is the designers, who stand at a higher level to design the building, to plan it. They look normally from more perspectives such as security, compliance, and like structural internal designs, if we talk about building a skyscraper. And the third team here, let's imagine it's you who owns this building project. We need to coordinate everything and own the project. Let's first look at what the construction team is doing. I hope this UI is familiar to you. This is AWS console. The first time I interact with the cloud technology, I use a console, right? With some mouse clicks, you can go to different pages, go to resources, and you can change the configurations and then provision the resources. This is a very intuitive way of doing so, but we also start thinking about how we can automate some process associated with provisioning the resources, right, to make the life easier. We use AWS CLI. And we write bash shell scripts. For example, here, how we create a VPC. We write AWS EC2, create VPC, and give the relevant information here. And similarly, we create subnets, internet gateway, these relevant, necessary resources in this VPC. When we want to run the workload, we create EC2 instances with the AWS EC2 run instances, etc. This is how we do it with AWS CLI. This is a very efficient way. It's automated. It's just like if we make example of the building the skyscraper, it's like you call a plumber to come to do something very technical, very special, very specific, and this is the job. Very good. After we learned about the construction team, let's look at what designers are doing. As I say, they are standing at a higher level. They need to consider more things as the construction team, right? They need to think about security, they need to think about compliance, etc. When we talk about these considerations, they need to somehow put it somewhere. They need to reflect it on a blueprint, which they can hand over to the construction team, so the team can start building as planned. And when we talk about the blueprint, normally we need a template. This is AWS CloudFormation. I hope it's familiar to you. It is a very good way of writing the considerations. Like you can see the security groups, instance types. They are very detailed, written in the template. It's very good, but if you have experience working with CloudFormation and similar technologies like Terraform, it can go to thousands of lines, right? especially when we build a skyscraper, we have 20 floors. You need to really write down what exactly is there on each floor and who is supposed to do what job. It can be very detailed, and what we want is to put focus on more high-level things. If you make this analogy, like when we plan this building planning, we have all the informations, which plumber would come to which floor and does what job at what time. Like this is the purpose of having such a template. After learned about what designers are doing, let's look at the third team, which is you, the owner of the project. What kind of experience do you want? Certainly you want something more intuitive and simple. What does it mean? It means you can describe what you want. For example, I want 3 floors of this building are offices. You want these plumbing systems on these floors are the same or like different, but in which way? You can just describe it. And these descriptions will be somehow generated into a template, which can be handed over to the designers. And then designers can work on it, then hand it over to construction team. That would be the experience we're looking for. Let's take the same example. If you want to provision a VPC resource on AWS, we can just write VPC equals to new ec2.vpc. This simple one line of code will help you provision the VPC and also all the associated resources. If you want to run the workload, we can provision the EC2 instance with this line of code, new ec2.instance. And here we refer the VPC we just created as a parameter here. This way, we have created with EC2 that sits exactly in this VPC we just created. This is the experience that we're talking about. Very intuitive, very simple. More examples. Here we created VPC and instance already. Another resource here is a bucket, which is also often a resource we created at AWS. Here you can just write bucket equals to new S3 bucket. We can provision it. And if you write more things here, you can for sure customize it. For sure, for example, give the bucket name or give the feature of versioning, etc. You can provision such a bucket. And what we need to do is to grant the permission to the instance to read or write to this bucket, right? And what we do here, very simple and straightforward, we write bucket.grant read and write instance.role. In this way, we refer the instance we created, the bucket we created, and give the right role to this instance. This is using the function to replace the normal way of doing this, like declaring a role with the policies. Right? If you have experience of defining the policies of a role, you have to go to the console or go to the template to understand the terms of policies and then make the changes. So this is very intuitive, and the beauty of this is you don't need to downgrade your experience of writing your application code. Writing infrastructure code can be as easy as application code, right? And after you have written these codes, it will compile into this. This is a template for the designers. It has more length because it's more detailed, but the beauty is you don't need to put focus on these details. You can care on the high-level things that are important things to the project, and all the details will be filled in by the CloudFormation. And here it gives you the minimal required IAM policy if you don't specify it. If you don't specify that. And we have called this it all the time, but it is actually AWS Cloud Development Kit, AWS CDK. This is what we are talking about. It has reached the general availability in 2019. It's relatively new, so it is very fair that you have not tried this. It is an open source multi-language software development framework, and with which you can choose the language that you are familiar with and the IDE that you are familiar with as well. It supports currently 6 languages, popular ones: Python, JavaScript, TypeScript, Java, C#, and also the Go. The good thing about being a coding language is you can receive the supports from it. For example, the autocomplete, inline documentation, and also it gives you abstraction layer, including the same defaults and reusable classes. These are all the benefits you can have when you define your infrastructure. Even newer topic is CDK8s. This is the project developed by AWS back in 2020, and then it was accepted by CNCF as a sandbox project. Then developers contribute to it as open source project, and it was generally available, I think, 2020, late 2020 or 2021. I think 2021. So what it does, if you have understood what CDK does for you, you can just compare this to what CDK does to CloudFormation is what CDK8s does to the Kubernetes manifest. Yeah, it can help you define the Kubernetes applications and architectures using the language that you're familiar with. It supports currently 5 languages: Python, JavaScript, TypeScript, Java, and Go. Benefits of being coding language, you can just leverage the best practices from libraries and also share with others easily. One thing, very important, it does not only work on AWS, it works on Kubernetes everywhere. Because what it generates is just pure Kubernetes manifest, right? You can apply it to different clusters as you want. This is the development workflow of CDK8s. If we look on the right side first, what we want to create in the end is Kubernetes resources. How do we achieve there? So first of all, we use CDK8 CLI, and we can initiate the project. And in the project, you can use any other project generators, but this one gives you more presets, which makes it easier. And in projects, you can start coding. You can create the charts and constructs using the CDK8's APIs. And once you are happy with your codes, you can synthesize it, and it will come to the manifests. And this is the last step of what you do with CDK8s. It stops here, and then you can enter the Kubernetes world with kubectl or GitOps tools. So these two are separate, which highlights that the benefits of CDK8s that you can run it everywhere. And also, you can share your codes with any others using the standard package managers. So it has become a good combination, right? CDK and the CDK8s. Everything under the Kubernetes, the cloud resources on AWS, you can provision with AWS CDK, including the VPC networking, the example we just did, and Amazon EKS clusters, etc. And everything above the Kubernetes application, you can use CDK8s. You can provision the Kubernetes resources, deployment, service, etc. You can use CDK8s to provision them. And with these two technologies, which follows the same design concept and technology, you can provision the whole stack on cloud. This is a clear advantage for the developers and for the infrastructure team. Great. So we also have a small demo for you to demonstrate how to use CDK and CDK8s. Martin?
Yeah. Can you give me the microphone?
Yes. Any questions? Feel free.
Yeah, one question. Is this just for creating new deployments, or how is the update process then? Can you then also update the resources with this flow?
Yeah, sure. It's just like...
Do you want to repeat the question?
Oh, yes, repeat the question. The question is whether you can only use CDK to provision the new architecture, or you can use it also to just make changes, right? And the answer is like, you can use CDK to maintain it just as code repo. Every time you can make changes to the codes, and then you can just synthesize it again. It generates a new CloudFormation template, and you can deploy it again.
And when you have a configuration drift, do you also bring that back into the code? Or
Yes, you go back to the code.
And you can also import the changes to the
Yes.
infrastructure?
Yes.
That's also possible. Okay.
Yes. We can talk later also in the apéro.
Okay. Thank you, June, for introducing the key concept, I think the key takeaway is there are different levels of abstractions, right? In computer science, we love abstraction. We have in AWS on this kind of CDK part, everything is API based in AWS. So you could use the APIs, and there's a time and place to use APIs. But then there's a time where you might use CloudFormation or CDK, just depending on which abstraction layer you're moving. A question, does anyone here write Kubernetes manifests regularly? Okay, perfect. So that's the interesting part for you then, I guess. So here I have a cdk8s project, and right here on top we can see that I'm importing this chart construct from the cdk8s library, and I'm using it here to define a web app chart. And what I'm doing, I'm using the cdk8s API to define a container. I specified the container image that I want to run in this web app. I have a container deployment, and then I'm putting a load balancer in front of this. So let's open the terminal and synthesize. So as June was telling you in this workflow, now this cdk8s CLI is taking the code that I've written in Python and is generating standard Kubernetes manifests. And if we take a look here, now in the dist folder, it created the manifest for the deployment of the container as well as for the load balancer. Well, if we compare this side by side, you could argue with me maybe that's not a huge benefit, right? The lines of code compared to the lines of YAML that this kind of definition requires. So let's actually move up an abstraction layer. So far we've used we call it level 1 APIs of cdk8s, which basically just mirror the Kubernetes manifest language. So now what I've done, I've decided, okay, I probably have multiple of these web app deployments. They should all have a similar setup, and the only thing they differ in is what application is actually running in the container. So what I've done, I've now defined here a Python class. And the Python class now, I've moved all of the code that we've seen before. So the load balancer, the container deployment, and here as well the container into this class. And I exposed some parameters in the constructor of this class. So now if I close this again, and we can basically delete all of this because we've moved it into a class. And instead I'm going to add these lines back in. Now I'm using this class. I'm initiating 2 web services. And the only thing they differ in is, for example, the image or the number of replicas or the port, just depending on what kind of class I've defined. So this key concepts of a programming language that we gain here by using cdk8s, right? We gain things like inheritance, control flow. We can integrate with we could make API calls. It's Python or the programming language of your choice. Right. So now next I decide, okay, the manifest we've seen, it's just a regular manifest which I could now take to any Kubernetes cluster like June was mentioning. But how about the integration between my infrastructure definitions? So let's say I've also defined my infrastructure, in this case an EKS cluster on AWS, using CDK. That I have here. So this is how this might look like. So now we are using the CDK API we create an EKS cluster, we define the Kubernetes version, and I've actually already deployed this just to save us some time here in the spirit of this demo. But now what I'm going to do, I'm going to look at this app.py file where all these stacks and the charts are defined or are initiated, are instantiated. And we see here I have this EKS deployment. And now I actually also want to use the Kubernetes manifest. So the first thing that might come to mind is, oopsie. Well, we saw how to generate it. It's a CLI command, cdk8s synth, and I get the YAML file. So I could just load the YAML files here in this Python, which I'm doing. And then the EKS cluster in CDK has an API to add the manifests. That's one way. But in the spirit of automation, I don't want to run multiple CLIs, right? I don't just want to have multiple steps where I first need to synthesize the Kubernetes manifest. So let's actually remove this again and scroll down a further. So here we also see the Kubernetes cluster, the CDK construct for it, deploying an EKS cluster, has this function to add an cdk8s chart. So there's a tight integration if you choose to between the two projects. So here now what I'm doing, the chart I've defined here. So I initiated a web app chart, which is the file that we looked at in the beginning. And instead of having to go through generating the YAML manually, I just passed that to this function call on the EKS cluster. And now CDK / the kube control running on the EKS cluster will take care of synthesizing the YAML and then also applying it. So let's actually go through this and do the deployment. So right now if I take a look at my cluster, there's nothing going on here. It's just a clean cluster that I deployed. And now I'm going to do CDK deploy. Right now we are in the world of CDK. We don't need to go through the step of first synthesizing the Kubernetes manifests. And actually I want to redeploy the EKS stack, which now it will find the changes. And given that I've added these new lines of code where it's making the API call and handing over the web app chart, it's synthesizing the CloudFormation and will apply it to the cluster. So while that's applying and updating, we can even move one step further in our abstraction layers. So there's one more thing, library is called cdk8s plus, and they are so-called level 3 constructs. So they have a higher abstraction layer, and if we compare this, the cdk8s API itself was very specific, very closely tied to how a Kubernetes manifest looks like, whereas the cdk8s plus libraries, they have a more intent-based API. So I'm on a higher level defining what I want to achieve. So I also brought an example here to have a look at this in action. So in this file, I might now be deciding, okay, I might want to add a cache between a database and my web app. I also want to somehow give access to a database from my web app. So what I've done here now, I still have the cdk8s imports, but I'm also importing from the cdk8s plus library. And I've decided, for my purpose, I'm going to use a I'm not going to run the database on the cluster, but instead I'm going to use Amazon Relational Database Service. So I'm just passing here in the constructor of this chart the database configuration. Now what I'm doing, I have two deployments. I deploy a cache here. Let's say I'd have a container image that is called cache. For the cache, as the environment variables, I'm passing in the connection string from my database. And the second deployment is the web app, where here I'm passing in the environment variables from the cache, how to connect to the cache. And right now they are not now known, right? So cdk8s will resolve them once I actually apply or synthesize. And then we talked about how we want to move to something more intent-based. This deployment we've already seen in the core of cdk8s. But now let's say I want to control the network access between those things, right? Nothing else except the web app needs to be able to access the cache. So what I've done here is, well, we have here the permissions to for a front office group to modify the cache and the web deployment. And here in the connections, we allow the web application or the web deployment to access the cache. If we talk about a highly available setup, we probably want to co-locate the cache and the web application in the same availability zone. So that's where we have this co-locate API. So the API that cdk8s Plus brings speaks actually in terms of what you want to achieve, not specifically on all the parameters that you need to configure. And now let's actually also synthesize this. And go take a look again at our dist folder. So now here, if we take a look, that's already getting quite a lengthy manifest that might be a bit more complicated to maintain and configure by hand. It's 300 lines, whereas compared to what we actually needed to write here was like 70 lines. So maybe I hope I can convince some of you that abstraction is a pretty nice thing, right? Let's actually go back, take a look at the deployment, because it finished off the CDK stack. The CDK stack took the CDK8s definitions and applied it to the EKS cluster. So if I check again my cluster, well, now it has those two web apps running. They each have their own load balancer. This one app I defined to have 2 replicas. Yeah. That's it in terms of the demo. So I hope I could give you a taste of how CDK8s and CDK works in practice. We'd appreciate it. I'd appreciate, here. We'd appreciate if you could fill out a survey. In our company, it's super important to get feedback. So your feedback helps us a lot. So there's the QR code for that.
It takes super short time, just 5 questions, one of them optional. So.
And you get to showcase your top level domain as well. Bragging rights.
Thank you so much. Last message from us. We have our Swiss Cloud Day on 26th of September. And everyone is welcome to still register to come. We welcome all of our customers, partners, or anyone who's interested in AWS to come. And yeah, we'll be there as well. Looking forward to talk to you there.
Excellent. Thank you so much.